Okay, now members, let us concentrate on how we handle a hexagon. A hexagon, if it's regular, all sides are equal. And so let us start with by dissecting the question. It says ABCDEF is a regular hexagon, forces 2N, 3N acting around SC. So if I call this one A, B, C, D, E, and then IF there. So they are telling me that the forces 2 newtons act along SC. Where is my SC? So you get a ruler and then you join to SC. So this is going to be my SC. So SC, they are telling me SC, these are 2 newtons, 2 newtons. Then 3 newtons acting around AE. Where is AE? AE is here. Our AE is going to be here. So I think this is our AE there. It's going to be 3 newtons. 4 newtons are on AF. Where is AF? These are our 4 newtons. 4 newtons. And ED 5. Where is ED? 5 ED, the direction ED 5 newtons. Always the order of letters will be giving you the direction always. So that is the ED. Now from there we are going to see find the single force that is stating both the magnitude and the direction. So now the idea here we have these forces. Now we need to resolve. We have 1, 2, 3, 4 forces. Now, how are you going to resolve? The only problem is coming in at this force. We need an angle there. Now, know that to get the exterior angles of a regular polygon, to get one exterior angle of a regular polygon, you get the number of, so we get 360 divided by the number of sides. So if you divide by 360 with 6, now our exterior angle, this one is going to be 120 degrees. If that is 120 degrees, means that now our balance here is going to be 60 degrees. Now, when you join this to this, remember these are regular polygons. So this side, this side, this side, this side. So when I join this, I'll be forming a rectangle. And now you will start always this one is going to be 90 degrees. So remember the whole of this. This is also an exterior angle, so this is going to be 60 degrees. Because the idea is, when I join this to this to the opposite side, whenever I join this to this side, that one is going to give me 90 degrees. And so if this is 90 degrees and this is 60, then the balance here is going to be 30 degrees. So that's always where the idea is coming from, for this to be 30. You see, this is when I join this and this, that I'll be forming a rectangle. Leave along my, you see the some sides are not, but if it's a regular polygon, this one and this one, and join this to this is always going to be 90 degrees. And so if this is 6 and this is 9, remember the whole is 180, the balance will be 30 degrees. So after getting those 30 degrees, let us see how we can resolve this force here. So to resolve this force, this was the one which wasn't giving, or which was giving us a problem. So now when we resolve this, I'll come, because it's way like this, I'll come like this, then I go like this up, then I go this way up, and then you go this way up, or you can complete this side, then you go like that. So you can complete that, then you go like that. Resolve this. So this one here is going to be, you see that this one is adjacent to this, so we get our force which is 2, then cos 30 degrees. Then you see this one is going to be opposite, it's going to be 2 opposite to this, so we get the force which is 2, then opposite goes with sine 30 degrees. Now we also have this force, good enough, we have its angle, so we just need to do this. So you see it's going like this, so you shall come this side, then we go like that. So when you come this side, this is adjacent, so we shall get 4 cos 60 degrees. Always the directions are very crucial. Then you see it's going up, this is opposite to be 4 sine 60 degrees. So after doing that now, we can come and resolve our, so resolving horizontally. Let us first start with the forces going the other side. First of all, we have this one on 5. Then consider they are going in the same direction. That's why we start with them. The same direction, that direction. We have 5 going that direction. We have also this one, 2 cos 30 degrees, then plus. And those the only forces, then we come to those opposite. So this one is opposite, so it's going the other side. So 4 cos 60 degrees. Is there any other force? I think that's all we have. So then our x is going to be, we press those on the calculator, so 5 plus 2 cos. So here I'm getting 4.7321 newtons. Now I solve vertically. So there I'll be getting my y. Vertically we have the first one, which is 3, then plus. Is there anyone which is going up again? Yes. Remember this one was going like this, then like this. So we also have that because our force is going like this, so we shall go like this, then up. So we also have 2 sine 30 degrees. Is there anything which is going up again? Yes. This one, then it goes up, then plus 4 sine 60 degrees. And is there anything else? We have this, we have this, we have this. I think we are finished. So then our y there is going to be, this is going to be, okay, plus sine. So here I'm getting 7.4641 newtons. So that is our force. So in simple terms now, start the resultant force, which we said is going to be x, y is going to be now our x, which is 4.7321. Then this one's going to be 7.4641. And these are in newtons. Now when we look at our, they're doing us to get the magnitude. So to get the magnitude of this, you can easily sketch. You see it's going to be like this, then that way. So this force, this is the x, which is 4.7321. And then this one is the y. You see it's also positive, 7.4641 newtons. Also these are newtons. So this is going to be our resultant there. So whenever you get a single force, it's very easy to get the resultant and also to get the magnitude. I mean to get the magnitude and then the direction. So our FR, this we shall get this using Pythagoras, the square root of this force, 321, the whole squared, then plus squared. So our FR here is going to be, when you press that on the calculator, so here I'm getting 8.8377 newtons. We give it 4 decimal places. Then direction, this one is going to be our direction alpha. So we said always the direction, get our tan alpha equal to the opposite over adjacent to 1. So our alpha will be now getting a tan on that. It's going to be 57.5 Z. The magnitude of the resultant force is that acting along a B. As simple as that. So that's how we handle that. So we are going to see some examples right now. They're going to give you these forces. What happens? So that's what I'm going to see in the next lesson. See you there. Please don't forget to subscribe to the channel.